In this example, the transmission network model is used to demonstrate small signal stability, using the Modal Analysis tool. For this example, study case 04 small signal stability should be activated, together with the scenario of the same name. This case illustrates the studying of small signal stability analysis, for which PowerFactory provides a Modal Analysis tool. This calculates the eigenvalues and eigenvectors of a network, including of course all controllers and power plant models. If all the electromechanical eigenvalues have negative real parts, we can say that the oscillations are damped, indicating system stability. Firstly, the toolbar has to be selected for modal eigenvalue analysis. The modal analysis is run using this button. We can access the initial conditions settings here. The settings of RMS values, and network representation as balanced, positive sequence, are automatically used. As the computation time for a large system can be too time-consuming to be practical, PowerFactory offers two computation methods, the QRQZ method, which considers all modes, and the selective modal analysis method, which reduces computation time because it calculates just a number of modes within a previously identified frequency range. In this example, we will use the QRQZ method. In the advanced options, we can select to calculate left eigenvectors, right eigenvectors and also the participation factors. Then the analysis is performed. We can then proceed to select plot type using this button. We have three options: eigenvalue plot, mode bar plot and mode phasor plot. Let us select eigenvalue plot, only considering oscillatory modes, and click OK. Modes that are stable are represented by green crosses, and unstable modes, that is any which have a positive real part, are represented by red crosses. In this case all the associated modes are stable. We can zoom in on the x-axis to look at the area of interest. These results can also be presented in tabular format using this button. The first columns represent the definition of the eigenvalue. Additional information about the damping is shown in the remaining columns. The oscillatory modes are those where imaginary part is non-zero, so the others can be removed from the filter. In this case, we are only interested in those where the damping ratio is less than 10%. We can again use a custom filter to reduce the list accordingly. Then we can sort to see the worst case. From here it is possible, by right-clicking on the row, to show the controllability, observability or participation factors using bar plots, or phasor plots. We can look at the contributions of the various generators by creating a bar plot of participation factors. Returning to the eigenvalue plot, if we double-click on one of the modes, we can also see the same information as was presented in tabular format. A bar plot or phasor plot can also be generated from here.